extra problems from, but we're covering plagiarism in pre-AP today. If anyone's curious about fighting plagiarism goblins, I can post it to the Google Classroom. Some tiny university somewhere in Pennsylvania has like basically a how to avoid plagiarism quiz where you're going through and clearing rooms of goblins. It's ridiculous. Alright. This is from our old AP book. So the first one, because it's going to be really relevant to the lab we're doing tomorrow and Friday, a 67.5 gram sample of an unknown hydrate of calcium sulfate is heated until all the water is driven off. The resulting mass of calcium sulfate is 53.4 grams. What is the formula of the hydrate? So what did we say a hydrate was? Water that attaches to the substance. So if we have a hydrate, it's going to be whatever the compound is plus water. In this case, it's calcium sulfate. So same principle is going to apply, though. We need to know how many moles we have of things. So we know the part that's just calcium sulfate is 53.4 grams. What's the formula for calcium sulfate? CaSO4. 8 means it's polyatomic. Ca comes with +2 charge, sulfate comes with a -2. Okay? And so, somebody calculate for us, please, what is the molar mass of calcium sulfate? Because we still have to get to moles. Okay. All right, and so then, huh?
We both got 136.
Okay. All right, this is why we have multiple people try things, because our math would not have worked well. So how many moles of calcium sulfate will this be? Okay. What do we get?
Oh, 0.39. I'm sorry, I said about 0.39.
And that's moles of calcium sulfate. How many grams of water did we have? How are we going to figure that part out? Subtract what we have. So we had 67.5 grams with H2O. We had 53.4 grams without. So we subtract. So how many grams of water did we have?
14.1.
And so then we have to find our moles of H2O. Molar mass of water. This is one you'll probably have memorized by some point in the year. 18.02. And that's 1 mole. And so what was our next step for finding an empirical formula? Divide by the smallest, which in this case, anytime you're doing a hydrate, your original compound better be smaller than your number of waters. If it is not smaller than your moles of water, then something has gone wrong. And what is 0.78 divided by 0.39? 2. So our full formula would be CaSO4 dot 2H2O. So it'd be calcium sulfate dihydrate. So we'll be doing this in lab with a copper compound. Alright, so next one down. I'm scrolling very slowly. Another really popular one is analyzing hydrocarbons by burning them and collecting the carbon dioxide and water. It's not that much more complicated, but it tends to freak people out the first time they see it, so I wanted to do one because they're really, really common, especially on the AP test. Alright. And remember, if you missed writing something down, the video will be on Google Classroom. Alright, so a 1 gram sample of an alcohol was burned in oxygen to produce 1.913 grams of carbon dioxide and 1.174 grams of water. The alcohol contains only carbon, hydrogen, and oxygen. What is the empirical formula of the alcohol? So which elements are going to be easiest to calculate of our carbon, hydrogen, and oxygen? Hydrogen is one of them, yes. Hydrogen and carbon. Because we know, where does all of our carbon have to go? From our alcohol, it all has to go to what? Carbon dioxide. And all of our H has to go to water. So the carbon dioxide is how we calculate our moles of carbon. The water is how we calculate our moles of hydrogen. The oxygen we'll deal with in a second. Alright. So we're still going to get to grams. Still going to get to moles. It's just going to be slightly different moles. So we're starting with 1.913 grams of carbon dioxide. Still have to get to moles, so we need the molar mass. Carbon dioxide, by the way, is 44.01 grams per 1 mole. And this is still CO2. Is CO2 going to help us find our empirical formula? No. What's going to help us find our empirical formula? Carbon. So we got to convert from moles of CO2 to moles of carbon. Yes, it's the same number. However, in the case of the water, it won't be, so we're going to write down the extra step. So for every 1 mole of CO2 we have, what do we have? How much carbon? 1 mole of carbon. Okay. Then we'll do the same thing for our water. How many grams of water do we have? Alright. Molar mass of water we said was 18.02 for every 1 mole of H2O. And so for every 1 mole of H2O we have 2 moles of H. Alright. So we accounted for all of our elements. We haven't done which element? Oxygen. So this is where these get particularly nasty. And I'm sorry, but they do. In addition to calculating how many moles of carbon we have and how many moles of hydrogen we have, let's go ahead and calculate our moles real quick just to get them there. We are in flex time now, and remember, totally writing a kernel essay. Alright, do we have moles of carbon and or moles of hydrogen yet?
Carbon is 0.0434.
0.0434 moles. Hydrogen,
0.130.
130. So this is moles of carbon and moles of hydrogen. Now, in addition to knowing how many moles we have of each of these, how are we going to determine how much oxygen we had?
By multiplying the...
What else did we know about our compound? We have 1 gram of it. So in that 1 gram, we have this many moles of carbon, this many moles of hydrogen. So whatever's left over has to be what? Our oxygen, which means we need to know the mass of these moles. So we're going to have to find mass and find mass. So can I get these folks to find me the mass of 0.0434 moles of carbon, and folks over there find me the mass of 1.30 moles of hydrogen? Yeah, this closest to me is carbon. Farthest from me is hydrogen. Okay, so we get for our mass of carbon? 0.5212 grams carbon. Do we have our mass of hydrogen? 0.131 grams hydrogen. And so then oxygen is going to be 1 minus these things. .347 grams O. Because this is part of a compound, it's just O. This is one of the few cases where it would just be O and not O2. Is it clear? Okay, so we'll just add the 8. All right, so what do we need to do with this mass? Get it to moles. Get all the things to moles. 0.3478 grams of O. The molar mass of O is 16 for all practical purposes. Do we need any other steps here? No, we're just getting to O. Let me know when we know how many moles we have. Say that one more time.
0.217.
0.02. I was like 0.2 sounds like a lot. All right, and so what do we need to do next? Divide by the smallest. So our smallest in this case is our oxygen. So we know oxygen's got to be 1. Carbon should be 2. Hydrogen will actually have to divide. Is it how close to exactly 6 is it?
5.99.
Then we're good, yeah. So our empirical formula is going to be C2H6O, which would probably be written as, because it's an alcohol, C2H5OH, because the OH is what makes it an alcohol. But either would be acceptable. All right, so yeah, the combustion ones tend to freak people out because there are a lot of steps. It's not technically anything different there's just more stuff to keep track of. And usually you're lucky and it'll just be a hydrocarbon with just C and H. It's when you have the extra O that life gets really fun. All right.